Now we'll see the last concept of this chapter, that is elementary operation or transformation of a matrix. That means you can change the element of any row or column without affecting their determinant value. Determinant you will study in the next chapter. Just remember that without affecting any determinant value, we can change the elements of any row or column. There are some 6 operations on a matrix. You can apply 6 transformation, that is 3 along the row and 3 along the column. Both are similar. Okay, these 3 and these 3 are similar. I have written the 3 here, first, second and third one. First one says that the interchange of any 2 rows or any 2 columns. Okay, you can interchange any 2 rows or column. For example, if I consider the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a square matrix, right, of order 3 by 3. Right, here the first row is always represented by R1. This is the first row, this is a representation, this is R2 and this is R3, third row. And columns are represented by, this is C1 and this will be C2 and this will be C3. These are the representation. Okay, here first transformation says that you can interchange any 2 rows or column. That means I can change R1 to R2. Okay, I can change the row R1 to R2. If I change R1 to R2, obviously R2 will changes to R1. So I can represent like this, the interchange of any 2 rows, or I can represent any 2 interchange of any 2 columns. I can write C1 interchange to C3. I hope you are understanding this one. First one, interchange of any 2 rows. I have written R1 is interchanged to R2. I mean, I am interchanging the R1 and R2. So now, this is now I can write this as matrices. Now, after the interchange of the row 1 and row 2, I can write this is now 4, 5, 6 and this will be now 1, 2, 3 and the row last one R3 is as it is. That is 7, 8 and 9. Right? If I interchange any 2 columns, C1 is interchanged to C3. Now along the columns, so this one I can write as C1 changes to C3. First I have read C3, right? So this will be now 3, 6, 9. Next will be here C2 is as it is, that is 2, 5, 8. Last one will be 1, 4, 7. I hope you understood this one. Okay, interchanging the any 2 rows or any 2 columns. You can't go with a row and column. It should be either row or should be a column. This is the first property. Second property says that, see the second property says that the multiplicative of the element of any row or column by a non-zero number. You can multiply by a row or column to the matrix by any constant number. It should be a non-zero. I consider the same matrix 5, 6, 7, 8 and 9. Now I can write R2 changes to K into R2. Is it clear? R2. The second row changes to K into R2. I mean multiply by the second row by the constant K. I can write R2 changes to 3R2. Is it clear? I am changing the only row R2. R2 is changes to 3 into R2. I have to multiply each and every element of R2 by 3. That I can write now. The new matrix will be 1, 2, 3. R2 is now we are multiplying by 3. So this will be 4 3s are 12, 5 3s are 15 and 6 3s are 18. The R2 is changed. R3 is as it is 7, 8, 9. So similarly this operation you can apply in the column wise also. I can change R1 changes to 5 into R1. Is it clear? Multiplying by any row or column by a non-zero constant. That is the second property. And third property says that, see here, the addition to the element of any row of column, the corresponding element of any other row or column multiplied by a non-zero element. I know you did not understand anything. Now we will see this one. R1, I can change the example R1 to R1 plus 2R2. Is it clear? I can add any 2 rows with a multiplied by the constant. So R1 changes to, first always you have to represent R1. It should be plus or minus, it may be anything, but first element should be R1. So R1 changes to R1 plus 2 R2. This means here only the first row changes. I can write this one. R1 changes. So second row is as it is 4, 5, 6 and third row is as it is 7, 8, 9. Only the first row changes, that is R1 plus 2 R2. R1, that is 1 plus 2 R2. Here this is R2, right? R2 is multiplied by 2. So this element will be now 8 and this is 10 and this is 12, right? R1, that is 1. Okay, here first element I am telling you, this is 1 plus R1, 2 into R2, 2 into R2, that will be 8. So 1 plus 8, this is equal to 9. So first element, you are adding the corresponding elements, okay. Now second one, 2 plus 5 into 2, it is 10. 2 plus 10 will be equal to 12. Is it clear? Or I can, last element will be 3 plus 6 into 2, that is 12 plus 3 will be equal to 15. This is the third property. Is it clear? These are the three properties. For this, we'll consider one more example. This is along the row. Now I'll consider the along column. I'll write C2 changes to C2 minus 2C1. Is it clear? The column C2 changes to C2 minus 2C1. Now you have to change only column 2. Column 1 and column third is as it is, right? So this one I can write 1 is as it is, that is 1, 4 and 7, and third is as it is, that is 3, 6 and 9. Now C2 changes to C2 minus 2C1. C2, that is 2 minus 2 into C1. 2 minus 2 will be equal to 0. Third one, C2, that is 5, right? Here I will write second element 5 minus 2 into C1. 2 into C1 will be 4, right? 5 minus 8. So it is equal to minus 3. Third element will be C2. C2 is now 8. Is it clear? 8 minus 2 into C1. That is 14. So 8 minus 14 will be, it is equal to minus 6. This is the three operations. I'll repeat once again. First operation says that you can interchange any two rows or column. Second operation says that you can multiply by a constant to the any row or the any column. Third operation says that you can add or you can subtract any two rows or the any two columns. I hope you understood the transformation of a matrix. We'll solve some problems based on that transformation so that you can understand it better. Before that, we'll see one more concept, invertible matrix. When the matrix is invertible. Suppose if I consider a matrix A, the inverse is exists only for the square matrix. Okay, if is a matrix A is of order M, then if there exists a matrix B of order M, so matrix order should be equal to same. Is it clear? Here A is the square matrix of order M and there exists another matrix B is of order M. Then if I multiply by A and B, okay, the product should be equal to B and A. That is equal to I. If it is, this is true. Actually AB is not equal to BA, right? But if it is AB is equal to BA and product of those matrix is equal to the identity matrix, then we can say that A is invertible. Okay, then A is a invertible. Inverse of A is B and inverse is represented by A inverse. You know this, A inverse. Is it clear? Here if I consider A is a square matrix of order 3. Okay, there should exist another matrix B of order 3. Okay, then if I multiply A and B, that is A and B, by multiplying this one I have to get the identity matrix of order 3. Identity matrix of order 3 means that should be 1 0 0 0 1 0 0 0 and 1. If I get the product of this one is this one, then we can say that B is the inverse of A as well as A is the inverse of B. Okay, the inverses exist only for the square matrix, not for the rectangular matrix. Rectangular matrix means if it is the number of rows are not equal to the number of columns, then we can say that it is a rectangular matrix. Next we'll see the theorem, uniqueness of a inverse. Inverse of a square matrix is unique if it is exists. I mean the inverse is always 1, not more than that. It will be equal to 1, and if it is exists, or else we can say that inverse of a matrix does not exist. Okay, you have to prove that inverse is unique. Let me consider the proof. Proof is simple. Okay, we'll consider one square matrix. Let A be a square matrix. You know that inverses exist for only for a square matrix. So let A be a square matrix. Clear? We have considered A is a square matrix, and we have to prove that there is only one inverse for A. Now let me consider B and C are the two inverse of a matrix. Okay, inverse of A. Is it clear? We have to prove that inverse is 1, but we have considered the inverse of a matrix is B and C. To say it is unique, we have to prove that B is equal to C. Right? If it is B is equal to C, then the inverse will be unique. Since B is the inverse of A, I can write A into B. Right? Product of A into B should be equal to B into A. This should be equal to the identity matrix. Right? And one more, C is also a inverse of A. By this I can write A into C. So this will be equal to C into A, right? Because C is also a inverse of A. This is equal to identity matrix. Now what we have to prove? B is equal to C. Let me consider B. So B, can I write B as B into I? If you multiply any square matrix by a identity matrix of same order, then it will be equal to B itself. You can check this one. You can consider any example and you can check B is equal to B into I. Now, can I write this one as B into I? I'll substitute as A into C. Is it clear? This is substituted as A into C. Since matrix multiplication is associative, this one I can write as B into A into C. Right? Matrix multiplication is associative. So that you can write B into A into C. What is B into A? We have B into A is equal to I. By this we can write this one as I into C. Is it clear? I identity matrix with C. So this will be equal to C. By this we have proved that B is equal to C. So the inverse of the square matrix is always unique. Remember this one. Next theorem. Don't worry, this is the last theorem. Okay. Theorem says that if A and B are the invertible matrices. So A and B are the invertible matrices means the inverse of A and B are exists of same order. Order of this A and B are same. Then you have to prove that AB whole inverse is equal to B inverse into A inverse. Similar to the transpose, right? You know that AB whole transpose is always equal to B transpose into A transpose. Similarly, this inverse is also. We'll prove this one. Okay. Proof is also important. Can expect. Okay. Now A and B are the invertible matrices of same order. If AB is invertible of same order, then product of A and B, AB is also invertible. Remember this one. Okay. Here in the question it is given that A and B are invertible. If it is A and B are invertible, we can consider product of those. That is AB is also invertible. This is possible only when the order of this matrix should be same. Otherwise the product of A and B are not invertible. Remember this, AB is invertible. Since AB is invertible, there exists an inverse of AB. Right? Inverse of AB we can represent by AB whole inverse. Is it clear? If it is A is the invertible, inverse of A we can represent as A inverse. Similarly here, AB is invertible, so inverse of that can be represented by AB whole inverse. By this we can write AB into AB whole inverse. This will be equal to I. Right? Since AB is invertible, we have considered this is the inverse of that matrix. So product of that should be equal to I. Now next step, we'll multiply by A inverse to the left side. If I multiply by A inverse to the left side, I can write A inverse into AB into AB whole inverse. This is equal to A inverse into I. We are multiplying by left side. Right? Since matrix multiplication is associative, we can write this one as A inverse into A. Okay. Then B and AB whole inverse is equal to A inverse is also a matrix multiplied by I. This will be equal to A inverse. Right? A inverse into A. This will be equal to I because A is invertible. So this one I can write I into B, AB whole inverse is equal to A inverse. So I is multiplied by this matrix. So this I can write B into AB whole inverse is equal to A inverse. Next step, can you say what we have to do? We need B inverse here, right? We'll multiply B inverse to the left. If I multiply B inverse to the left, so this will be now B inverse into B into AB whole inverse is equal to B inverse into A inverse. Since B is invertible, B inverse into A will be equal to identity matrix, right? It is given that A and B are invertible. So this is equal to I into AB whole inverse is equal to B inverse into A inverse. By this, if you multiply I to the matrix, so this is I can write AB whole inverse is equal to B inverse into A inverse. So clear? To prove this, AB whole inverse is equal to B inverse into A inverse. Here the thing is, you have to remember this one. AB is invertible. Without this, we can't prove this one. Okay? AB is invertible, then you can proceed. Next, we'll see the problem based on the transformation. The question is given, by using elementary operation, find the inverse of this matrix. This type of problems are important for 3 marks. This is very important, okay, compared to those theorems. Now, you have to find the inverse of this matrix. See, to find the inverse, in the next chapter, you have another method. That method is very easy. But if they mention by using the elementary operation, then you have to use this transformation only. Otherwise, you will not get the marks, okay. Now, the matrix A is given. Here matrix A is given, we have to find the another matrix B that should be, product of A and B should be equal to the identity matrix, right? This is your work, you have to find the matrix B. Now, the method is, first you have to write the matrix A is equal to I into A. This is the first step. Is it clear? A can be done as I into A. Listen carefully, I will substitute the value of A and in matrix A, that is 1, 2, 2, minus 1. Here I will write the matrix I is of order 2. I can write 1, 0, 0, 1 and I will write A as it is. Is it clear? Now, next step is you have to convert this matrix into an identity matrix. Is it clear? The product of A and some matrix should be equal to the identity matrix. For that reason, you have to convert this matrix into the identity matrix. That means you have to convert this is into 1. Anyway, here 1 is there, or else you have to convert this element into 1 and this into 0 and this element into 0 and this into 1 by using the transformation. Here, while applying the transformation to this matrix, you have to apply the same transformation to this matrix. Finally, you will get the identity matrix here. You will get another matrix here. This matrix will be the now inverse of the matrix A, because A into some matrix will be equal to the identity matrix. I hope you understood this one. We will solve this problem so that you can understand it. Now, as I told you, you have to convert this one into the identity matrix. Here, see, 1 is there, 2 is there, 2 and minus 1. Here I have to convert this one into 0 and this, this one into 0 and this is into 0 and this is into 1. First what I do is, I will write R2 changes to, I need this is 0, right? This element is 0. One by one you have to do. I can write R2 minus 2R1. Can we do this one? R2 is 2 minus 2 into 1 into 2. 2 minus 2 will be equal to 0. Right? Here this you will get a 0. So R2 second row changes to R2 minus 2R1. Now I will apply this one. Here we are changing only R2. So first row will be as it is, that is 1 and 2. R2 2 minus 2 into 2. So this will be equal to 0. Here minus 1 minus 2 into, right, 2. That will be minus 4. Minus 1 minus 4 will be equal to minus 5. Is it clear? I hope you understand this one. This is equal to same thing you have to apply here also. Right? So the first row will be as it is, that is 1 and 0. And second row will be R2 minus 2R. 0 minus 2 into 1. It will be equal to minus 2. Next R2, that is 1 minus 2 into 0. So this will be equal to 1. So clear? This is the first operation. R2 changes to R2 minus 2R1. Now here we got minus 5. Right? But we need it in the form of 1 0, 0 and 1. So what I can do? I can write R2 changes to R2 divided by minus 5. Right? If you divide by minus 5, this will be equal to 1, or 1 by minus 5 into R2. Is it clear? You can write like this, or you can write this one as 1 by minus 5 into R2. Anyway. Is it clear? R2 changes. Now we'll change the R2. Change the matrix R2. Sorry, row R2. So first is as it is. That is, first row is 1 and 2. So 0 divided by minus 5. Okay, this will not change, right? That's the reason we can divide by minus 5. So this will be 0. And here minus 5 divided by minus 5 will be equal to 1. Same thing you have to apply to here also. So this one now. Okay, sorry, here A you have to write. So first row is as it is. That is 1 and 0. Next will be, you divide by minus 5. So this is now minus and minus will get cancelled. This is now 2 by 5. And this is 1 by minus 5. So clear? 1 by minus 5 into matrix A is as it is. Now we change this one, we have to change into 0, right? We got 1 and this is 0 and this is 1. Now only the thing is you have to make this element into 0. So you have to change the row R1 without affecting this one. Okay, because this one we need. So what we can do? Now R1 changes to, right, R1 minus, what we can do? We need here, this is 0. So here we have to multiply by 2. Right, 2 minus 2 will be equal to 0. So R1 minus 2 into R2. Is it clear? R1 minus 2 into R2. So this one we can write as, now we are changing the row 1. So 1 minus 2 into 0. So it will be equal to 1. Here 2 minus 1 into 2. It will be equal to 0. So last element will be 0 and 1 as it is. So this is also, we have to change R1. So that is 1 minus, right? So this will be now 1 minus 2 into 2 by 5. So this is now, LCM will be 5. So 5 minus 4 is equal to 1 by 5. So clear? First element will be now 1 by 5. Second element 0, right, minus 2 into R2 is now 1 by 5, right, minus 1 by 5. So minus into minus plus 2 by 5. Clear? So second element will be equal to 2 by 5. Third element, this is same, 2 by 5 and minus 1 by 5 into A. So clear? Now here we got the identity matrix, that is 1 0 0 1. So this is the inverse of a matrix A. I hope you understood this one. This is the inverse of a matrix A. How to check this one? You have to multiply this matrix with the matrix A. If it is equal to 1 0 0 1, then this is correct. Is it clear? We'll solve some more problems, okay? So the inverse of, now I can write inverse A inverse is equal to, so that is 1 by 5 and 2 by 5. So this will be 2 by 5 and this is minus 1 by 5. This is the inverse of a matrix. Now we'll see the next problem, that is by using elementary operation find the inverse of this matrix. Similar to that problem. So this is also 2 by 2 matrix. Actually I forgot to say one thing. While doing the elementary operation, either you have to go with the row operation throughout the problem, or you have to go with the column operation, row or column. Both you can't use simultaneously, okay? Either this should be there or this one, but I just stick to one. Here also we'll use the row operation. And one more thing, it is not compulsory that you have to use the same operation whatever I used. You can use anything, but the thing is finally you have to make first matrix as the identity matrix, okay? Then we'll consider this one. What is the first method? You have to consider A is equal to I into A, right? I'll substitute the matrix A, that is now 2, 1, 1 and 1. So identity matrix is now ordered to 1, 0, 0, 1 and A. Is it clear? Now I have to make this as 1 and this as 0. This is 0 and this as 1. What I do is, I'll change the row R2 into R1. Is it clear? If I interchange this one, obviously I'll get 1 here, right? And this will be 1. Here also I'll get 1. So that's the reason I'll change R2 into R1. So if I change this one, both are interchanged. So first operation this is. So this will be now 1, 1 and this is 2, 1. Same thing you have to apply here also. So this will be 0, 1 and 1, 0. So this will be the matrix A. Now here this is 1. I need this as 0 and this as 0, right? So what I do is I'll change R2 changes to R2 minus 2R1. Is it clear? R2 second row changes to R2 minus 2R1. So that this will be now equal to 0. So the operation will be first row is as it is, that is 1 and 1 R2, that is 2 minus 2 into 1, that is 2 minus 2 will be 0. This is 1 minus 2. 1 minus 2 will be equal to minus 1. Same thing you have to apply here also. So this is first row is as it is, that is 0 and 1. So this is now 1 minus 2 into 0, 1, right? 0 minus 2 into 1. 0 minus 2 into 1, it will be minus 2 into A. So clear? Next is, so I'll write that step here, that we got 1, 1, 0 minus 1. This is equal to 0, 1. Next 1 minus 2 and A. Now we need this as 1. So what we can do? We can change R2. Yes, right? R2 is multiplied by minus 1. Multiplied by minus 1. So that is now minus into R2. So this one I can write this as R2 is changed. So R1 is as it is 1 and 1. So multiply by negative number sign. So this will be 0. So minus into minus will be plus 1. So this is equal to first row is as it is, that is 0, 1 multiplying by a negative number. So this is negative sign minus 1. So this will be minus 1 to minus will be plus 2 into A. Now we got 1. Here we have to make this one as 0. What we can do? Directly you can subtract this, right? R1 minus R2. So 1 minus 0 will be 1. 1 minus 1 will be 0. Is it clear? We can change R1 without affecting this one. R1 changes to R1 minus R2. Now we are changing the row 1, that is first row 1 minus 0. It is 1. 1 minus 1. It will be equal to 0. So this is as it is 0 and 1. We got identity matrix, right? So this is equal to 0 minus of minus 1 will be plus 1. 1 minus 2. It is minus 1. So the last column is, last row is as it is. That is minus 1 and 2 into A. So we got the identity matrix here. So this will be a inverse of a matrix C. You can check this, multiply these to A and this. That should be equal to the identity matrix. I hope you understood this one. In this 3 by 3 matrix is also there. Actually those 3 by 3 matrices are not important. This 2 by 2 is important. I'll explain one. Some more problems are there in the exercise. You have to solve those problems. Okay. I think these problems are little confusing. That's the reason I'll solve one more problem. That is 2 by 2 matrix. This is the exercise problem. Okay. 2 by 2 matrix. Here also order is 2. First what you have to do, A is equal to I into A. Right? Identity into A. First I'll consider this is now matrix A. That is 2, 1, 7, 4. And this is will be equal to identity matrix will be now 1, 0, 0, 1 into A. Okay. One more thing you have to remember while applying the row or the column operation. If you get any row, one full row or the full column is equal to 0. If I get like this 1, 1, 0, 0, then inverse of this matrix does not exist. Or I can get 0, 0, 1, 2, 1. So this is also inverse of a matrix does not exist. Remember this. If it is any row or column of a matrix is 0, then inverse of a matrix does not exist. Okay. We'll check this one. So 2, 1, 7, 4, 1, 0, 0, 1, 8. Now I have to convert this one into 1. This is into 0 and this into 0 and this into 1. What I do is I'll change R1 changes to R1 divided by 2. Because here 2 is there, I need 1. Anyway, or you can change R2 changes to R2. Okay, we can't do this, right? R2 7, you have to multiply 2 into some number. That should be equal to 7. So this is not possible. For that reason, we can change R1 into R1 divided by 2. We'll do this one. So now only the first row changes. That is 2 by 2 will be equal to 1. 1 by 2. And this is as it is 7 and 4. Here also have to apply same thing. So this is divided by 2. This is 1 by 2. And 0 by 2 will be 0. And this is 0. And this is 1. And this is equal to 8. Is it clear? Now I can do this one, right? R2 changes to R2 minus 7R1. Right? We'll do this one. R2 changes to R2 minus 7R1. Is it clear? So now only the second row changes. So first row is as it is 1 by 2. So 7 minus 7 into 7. It will be equal to 0. 4 minus, right? 4 minus, that is 4 minus 7 into 1 by 2. Right? So the LCM will be now 2. So this is now 8 minus 7 will be 1 by 2. So this is also equal to 1 by 2. So this is equal to, here also I have apply the same thing. First row is same, that is 1 by 2 and 0. R2 0, right? This will be 0 minus 7 into R1 is 1 by 2. So it will be equal to minus 7 by 2. Minus 7 by 2. So this is now 1 minus 0 into 7. It will be equal to 1. Is it clear? I'll write this one here. So we got 1 by 2. Then 0 1 by 2. So this is equal to, the matrix will be here 1 by 2 0 and this is minus 7 by 2 and 1 into A. Now we have to make this one as 0 and this one as 1, right? So what we can do, this should be equal to 0. If I subtract R2 minus R1 minus R2. So 1 minus 1 will be 1 minus 0 will be equal to 1. 1 by 2 minus 1 by 2 will be equal to 0. So what I do is R1 changes to R1 minus R2. Is it clear? R1 changes to R1 minus R2. So R1 changes now. So 1 minus 0 is 1. 1 by 2 minus 1 by 2 will be equal to 0. So this is 0 and this is 1 by 2. So this is equal to, now this is now R. So this is now 1 by 2 minus of minus plus 7 by 2. 7 plus 1 is 8 by 2. So 8 by 2 will be equal to 4. I hope you are understanding this one. So next one, R0 minus 1. So it is equal to minus 1. So last is as it is, minus 7 by 2 and 1 into 8. Now here we got 1 0, 0 and 1 by 2. Here we need 1. What we can do? Divide this one by 1 by 2, right? This will not change. This will be 0 itself. So R2 changes to R2 divided by, multiply by 2. Sorry, not dividing, multiplying by 2. So because we have to cancel 2 and 2. So multiply by 2. So this will be now 1, 0, multiply by 2. 0 into 2 will be 0. 1 by 2 into 2. 2 and 2 will get cancelled 1. Right? So this is equal to, so this is now 4 minus 1. Minus 7 by 2 into 2. 2 and 2 will get cancelled. Minus 7. So 1 into 2 will be equal to 2 into E. Here we got the identity matrix. So this is the inverse of a matrix C. That is 4 minus 1 minus 7 and 2. I hope you understood this one.